a lot of today is review. A lot of it is actually review of things that we've done in the past. Well, let me get into it. We're going to also learn how to graph linear equations. A linear equation is an equation that has an x and a y value, okay? And the x and y correspond with each other. Now, you're going to have a problem. You're going to have problems like this on your homework. Use the given x values to write solutions of the equation y equals 4x plus 2 as ordered pairs. Basically, all we're going to do is we're going to plug 1, 2, 3, and 4 into here, figure out what y is. Remember how I said yesterday, you have these corresponding, for every x, you have a corresponding y. You have a y that goes along with it, okay? They're like matching shoes, okay? This one goes with this one goes with this one goes with this one. So, what I suggest and what you should do in order to solve a problem like this, you should make yourself a table that looks like this. And you have x here, and you have y here, and you can even write, and what I want you to do, this is what I want you to do actually. Y equals 4x plus 2. Then your x values are 1, 2, 3, and 4. Because that's what it's asking for. What is y when x is 1, when x is 2, when x is 3, and x is 4? So what do you think we have to do? Parker. Plug 1 in for x. So we take 1, and if we plugged 1 in here, we would have y equals 4 times 1 plus 2. So what is y? Jeremiah? 6. Next one, we plug 2 in for x. So we'll have y equals 4 times 2 plus 2. What's it going to be? 10. Leah? 14. You with me? Cesar, are you with me? What's going to go here then? Say that again. Good. Very good. Now, next step. Says, as ordered pairs. So we need to answer the question that's being asked. So we need to write our ordered pairs. We have x and y. Remember? Which comes first, x or y? X. Oh. I don't want x. When x is 1, y is what? 6. When x is 2, y is what? Jeremiah? 10. When x is 3, y is what, Kevin? Sure, look at the chart. 14. And when x is 4, y is what? Jonathan? 18. Okay. As ordered pairs. Now, you guys have done this a few times already, where we could easily graph it. You know how to graph this. This is an ordered pair. We would go over 1 and up 6. We'd go over 2, up 10, over 3, up 14, and so on. And that's where you make a graph. And, believe it or not, we could use that graph to find every single y value and every single x value, and we don't have to keep plugging it in. But we'll get to that. Okay? It's pretty simple, actually. And again, this is just a review. All we're doing is plugging these numbers in. So, again, the next one. What is it that I have to do? What should I do? Leah. Make like a box thing. Let's use a good word. How about a table? Okay. So we can do this, and we'll save a little bit of time by going x here, y here. What goes here? Alexis. Plus 2. Oh, plus 2. Okay. And I'm not even gonna keep writing this in here. You don't have to either, because I know that you know all you got to do is plug x in. What goes here down this column? Cesar. Yeah, down this column. 2, 3, 4, 5. Okay. Now let's start plugging it in. When x is 2, what is y? Kevin. 8. So we take 2, plug it in there. So we have 3 times 2, which is 6, plus 2 is 8. When x is 3, what is y? Lacey. 11. When x is 4, what is y? Marissa. 14. And when x is 5, what is y? Gracie. 17. Okay. Yes, sir. Yes, in this particular equation, because that's the way that this one works. Okay? But it doesn't always work that way. So be careful looking for the pattern. Be careful trying to do that, okay? What you should do instead is always plug this in and then find the y. Always do it that way. I know it seems longer, but you know what? All of a sudden, when you get to Mr. Boquist and you start looking for that pattern, all of a sudden you're going to end up running into problems, okay? So then it says we need to write them as ordered pairs, so let's write them in ordered pairs. We have what? 2, 8. What's my next one? 3, 11. What happened to that comma? It's weird. Next one is, Lacey? 4, 14. Cesar, what's my last one? 5, 17. There we go. And then we could graph it out. Next kind of homework problem you're going to see. We can check to see if solutions. This is, when we first started algebra, this is what we did. We checked to see if things were correct. Except we're adding a little twist to it. Now we have an x and a y. X and a y we have to plug in. Okay? Remember, when we have an ordered pair, and we have it like this, this one, which is this? Is this x or is this y? This is x. X always comes first. So it's always x, then y. So is this 3 my x value or is this 3 my y value? Tell me in. This is my x value. So what I'm going to do is I'm going to plug these numbers in. I'm going to take this 21 and I'm going to plug it in for y, and I'm going to take the 3 and I'm going to plug it in for x. And so I'm going to say 21 equals 7 times 3. Is that a true statement? Yes. So it says determine whether ordered pair is a solution. I would say I'd take my yes. Remember doing that? Good. Next one. What do we have to do? Jonathan. Put 20 in for y. Okay, so 20 equals. Then what? Then 4 what? Oh, okay. 5 times 4. Is that a true statement? Yes. So I would say yes. Now, I don't know why they don't do this, but they didn't. What if, let's just pretend here for a second, that we didn't have 4 here. Let's just pretend we had 3. And so then we plugged all of our numbers in, and we would have 20 equals 5 times 3. Is that a true statement? No. So what would we do? No. We put a big fat no. No. No, it's not a solution. Remember doing that? Okay. Good. Yeah, well, you got to show, yes. Remember, Jonathan, when I demonstrate up here, that's what I want you to do on your homework, too. Don't start changing things. Here we go. The graphing portion of it. Aaliyah, question. We're actually going to do the graphing. Look. Yeah. Look, though. Look. I made some nice sheets for you. You don't have to draw this. No. It is beautiful, Gracie. That's one of the prettiest graphs I've ever seen.
Thank you.
You're welcome. Let's just skip that. Now, you're going to have questions that look like this, that say, use the graph, and this is actually what your dad did.
Oh.
Okay? He made the graph, and then he used the graph to find the y.
Oh.
It says when x is 4, what is y? Remember, x goes across, y's go up and down. So when x is 4, so when x is over here, how far up do we have to go? Kevin, 2. So it says find the given value of y. So the given value of y equals what? 2.
Why does it go?
Okay, wait, one at a time. One at a time. Yes. All the way across. What? Can you come up here and point to what you're talking about?
All the way across.
Because this is a linear, this is an equation. Because for the equation, the specific equation that they graphed, remember how the last time we graphed it x's and y's? Okay? There is an infinite number of x values, and there's an infinite number of y values. They all go together. That's what. Like, if I asked you this question, if x is, let's say x is -2, what is y? What is it? -1. Okay. What if x was -4? What is y? -2. It's way over here. Now, our graph isn't big enough, but if I said I could figure out y if x was -736, I could figure out y. but I'd have to have a much bigger graph. You understand? Does that make sense? Does that tell you? Does that explain to you guys why? No, it doesn't. Okay.
There's no pen there. What's it supposed to do?
You know what? That will answer. When we get to the next part of it, it will explain why. Okay? I will show you why.
Oh.
I will show you. Yes, WHY.
Oh.
That makes sense. Ah, I see the confusion. When we actually graph them, this line, let me tell you this. This line represents every single possible solution to the equation for this line. Let's say this equation, let's come up with it. Let me try and come up with 2 equals. What is it? X is 1. I think this is. I'm fighting with it right now. I'm trying to. I might be able to come back to it and give me a moment to think about it for a little bit, okay? Yes.
Do you do it the other way? Put the line in the other side?
Yes. Every equation, every linear equation has a different line. Okay? The next one I show you will be a different line. You'll see. You'll see. You'll see. Just wait. Just wait. See how it turns? Yes, it's in a different quadrant.
Squares, like could it be a negative square? Or you could like
It is in a negative square.
no, like yeah.
Oh, could it be this way? Could there be an equation that has a line that looks like that?
Yeah.
Absolutely. Yes, there is. Yes.
How do they know where to and could they go at any angle or something?
Let me skip. Let me skip and show you. Let me skip and show you. This will probably answer your question. Okay. We have an equation. Y equals negative x plus 2, or minus 2. Okay? So we're going to make a graph of this equation. The first thing we need to do is find an x and a y value for each. So what we're going to do is we are going to make a little chart here, a little table. I know, it's beautiful, isn't it? Actually, I'm only going to do 3. I don't need to do 4. Just a second. This is my equation, correct? Does that make sense? See what I've done here? Now, remember, for every one of these equations, there's an infinite number of possibilities for x and an infinite number of possibilities for y, but they match up. There's a corresponding one. They go together. Okay? They're like pairs of shoes, like I said. This shoe goes with this one, this shoe goes with this one. Well, pick a number for x. Just give me a number. 3. Okay. When x is 3, what is y? Well, so let's plug this in. Let's take this 3 and plug it in right here. So now my new thing will be negative 3 minus 2. And remember our rules we got right here. We're subtracting a positive number. So what is y? No, negative 3. If we had our number line, remember our number line? Negative 1, negative 2, negative 3. We'd put our finger at negative 3. Minus 2, so we're subtracting a positive. What way do I go? I go to the left. How many? 1, 2. So it's going to be -5. So -5 goes here. So when x is 3, y is -5. That's for this equation. Does that make sense to you so far? Does that make sense to everybody so far? Kind of? We're going to find different x's and y's. Give me another x. Remember, we want to keep it close to the center. Lacey. 5. Okay. All right, 5. So now we're going to find out the corresponding y that goes with it. So we're going to put -5 here, -2. Be what? It's going to be -7. Sorry. I realized it. So this one, these are all the possible solutions. All I'm doing is finding possible solutions for this thing. Okay? What if x was, let's say it was 1. What is y? -3. Now what we would do is if we made a graph, and hopefully let's make sure it works. Make a function table, just like we just did. They decided to use -1, 0, and 1. That works. That's what the PowerPoint, that's what the book decided to do. We just chose different x numbers. It doesn't matter what x numbers we choose, because you'll see. Then we write them as ordered pairs, which is what we kind of did. We had 3, -5, 5, -7, 1, -3. And then we can take those numbers. That's how the line gets there. Now, does it all come together?
How is that find y if you already have the y?
We didn't have them. It was asking what is y when x happens to be this. Now notice, this is the 3 dots that they made. Correct? Well, what were the numbers that we chose? We chose what? -3? Let's look.
3, 5, and 1.
We chose 3, 5, and 1. Okay.
We have the.
Just a second. Just a second. Notice, our numbers should fall on this line as well. Don't they? 3, -5, 1, 2, 3, 4, 5. Our numbers would fall on that line. 5 would have been way down here. 1 was right.
Oh.
Every single one that we find is going to fall on this line. Okay?
Can you draw them out?
Can I draw them out? Well, 3, -5 would have been right here. The next one would have been 5. It would have been way. No, then that's why I asked you. We got to keep it close to the center, because otherwise, got to make a much, much bigger graph. So the next one would have been here. Now, what happens if we found a solution that wasn't on the line? What did we do? No, we don't make a new line. We didn't solve it right. We made a mistake. Every solution that we found had to be on that line, okay? So, all I'm asking you guys to do is when you make your graphs, when you do the graph, okay, Make sure that they're all on the same line, and if they're not, you made a mistake. Now, the next thing, let's go back to where we started this whole confusion. Let's look at our graph here. They were asking us questions like, when x is -3, what is y? Look at this. If we're making our table, when x is -3, what is y? Look at our graph.
Oh, I know.
What is it? What is y? When x is -3, where does this line cross y? It crosses it at 1. How about when x is 2, what is y? What do you want to guess, Cesar? Give me a shot. When x is 2, it crosses at -4. Very good. Here's one more question for you. When y is 3, what is x? Alexis. When y is 3, what is x? Want to try, Torrance? No, when y is 3, when we go up 3 and we got to find our line, where's x cross? Lacey. -5, correct. Okay? All right. That was a lot. But really, truly, I think you can handle it. Your homework. You're going to be making graphs. You're going to be finding solutions. You're going to be doing those 3 things. The homework I want you to do is going to be on page 648, numbers 12 to 28 even. Hey, you have to make 4 graphs. You have to graph 4 linear equations. Notice I have a sheet with 4 of them on it.